These raw materials, sinter, iron ore and coke, meet each other at the blast furnace, where they are fed into the top of the furnace along with a further ingredient, limestone. A hot air blast, from which the furnace gets its name, is injected through nozzles called tuyeres situated in the base of the furnace. This blast raises the temperature in the furnace to white hot intensity, around 2,200 degrees centigrade. This extremely high temperature is needed for the chemical reduction and melting of the sinter and iron ore to form a pool of molten iron in the lower part of the furnace, just above the hearth. The limestone that's been added combines with impurities and forms a liquid that floats on the surface of the molten iron. This is known as slag. As the molten iron is tapped from the furnace, the slag is skimmed off and taken away for use in other industries, such as road building and cement manufacture. The molten iron, or hot metal as it's known in the industry, is still impure and contains unwanted elements such as sulfur, phosphorus, manganese and silicon. To make steel, these elements must be removed or reduced, and other elements added, depending on the type of steel being made. The carbon content, at about 4%, makes iron very brittle and unsuitable for rolling or forging. And although iron can be used for castings, most of the iron produced is processed into steel.
Polymers are found in nature. Spider silk is one of the strongest of the natural polymers. Chemists have always sought to duplicate what is found in nature, and especially in this process called polymerization. An example of that would be to take these paper clips and allow each one to represent a molecule called a monomer. We can then link these monomers together in a chain to form what is called a polymer. We can see that process happening if we take these paper clips and gradually add them to our reaction vessel, this box. Closing the vessel and carrying out the chemical reaction, usually with the aid of a catalyst, we can then remove the polymer, a synthetic fiber. But what you're interested in seeing would be the real chemistry, and one of the most useful of the polymers today that we find is nylon. Here to this chemical we're adding a few drops of phenolphthalein indicator. It's basic, and therefore the color will allow you to see this layer. We're going to pour in a second layer of another chemical. The two chemicals form two separate layers. If we reach in to the interface of those two layers, where the molecules come together and react, we can pull out a synthetic fiber. This synthetic fiber, slightly colored by the phenolphthalein, is nylon. An application of polymerization can even be found in the toy store in the form of string confetti.